Hi, Noise Control Engineering, NCE, has been awarded a small business innovative research contract to develop a quieter and more efficient abrasive blasting nozzle. My name is Jeffrey Komrower. I'm a senior engineer at Noise Control Engineering. And before I get into the specifics of this SBIR effort, I'd like to tell you a little bit more about our core capabilities. Noise Control Engineering is a very successful acoustical engineering consulting firm that specializes in noise and vibration control for industrial, commercial, and marine applications. Noise is a big issue in today's world. In the military, disability claims related to noise-induced hearing loss and tinnitus are estimated to cost Veterans Affairs close to $6 billion annually. Upticks in hearing loss claims have also been observed by industry in general. Workers on ships as well as on land benefit greatly from noise control measures as lower noise levels lead to increased productivity, lower fatigue, and a reduced risk of hearing damage. A quieter work environment reduces the safety risk associated with these factors as well as their heavy financial cost. Noise control engineering has the resources and experience to help. The company has a significant technical history, and our roots lie in the marine industry. In the 3 decades since its founding, Noise Control Engineering has become the leading designer of quiet vessels serving the marine industry worldwide. We develop solutions for noise and vibration problems aboard vessels, both commercial and military, and have participated in hundreds of shipbuilding programs. We provide our marine clients with acoustical design support during all ship design phases from concept design through post-delivery. We work with naval architects, owners, and shipyards to specify quiet equipment, identify vessel layouts that will minimize the need for acoustical treatments, define structural arrangements that result in low noise and vibration, develop control strategies, all to ensure that the ship will meet all noise and vibration requirements on board and underwater. We use a number of analytical tools to assist with our pre-construction assessments of ship noise and vibration. The primary tool is our proprietary acoustic prediction software, Designer Noise, which is a great example of a successful SBIR project. Designer Noise was initially created under SBIR N172-134 and further developed under the Office of Naval Research contracts, and is a proven tool for creating quieter vessel designs. Due to its success and accuracy in shipboard noise predictions, Designer Noise is used by the U.S. Navy, naval shipyards, and other commercial customers and has been implemented on hundreds of ship programs to identify noise problems and solutions. It enables shipbuilders and designers to produce quieter vessels more effectively and efficiently through early assessments of noise and treatment optimization. The software is also utilized extensively in noise and vibration diagnostic efforts for existing vessels. SBIR N04-221 was another successful SBIR program, which involved the development of a unique spray-on damping compound to address noise issues on CVN aircraft carriers. In this project, we weren't the prime, but were a vital partner in demonstrating the ability of this technology to reduce noise levels in the high aircraft carrier environment. This product is now commercially available. Since 2011, Noise Control Engineering has been a prime contractor to O&R Code 34, Noise-Induced Hearing Loss Program Manager, and subsequently to the Auditory Neuroscience and Performance Program Manager. The primary focus of this multi-year program was to investigate and implement methods for reducing noise on naval vessels. Key accomplishments include the following: conducted numerous extensive testing programs during flight operations on CVN and amphibious platforms to quantify noise levels from the Joint Strike Fighter aircraft and develop noise mitigation strategies for the gallery deck compartments. Being the primary contributor to MIL Standard 1474E Requirement 4 on shipboard compartment and equipment noise. Conducting a study for the Defense Safety Oversight Council to identify the top 10 most significant steady-state noise sources within the Department of Defense and developing noise source reduction conceptual design plans for each source based on the best available engineering control methods. And in conjunction with O&R, we were able to transfer technology developed to the Bureau of Reclamation hydropower plants, where Noise Control Engineering became the prime contractor to reduce noise in these plants. Our key resources are our highly experienced personnel who have supported over 280 marine projects and hundreds of industrial programs in the noise and vibration areas. Details of these projects can be found on our website, but highlights include performing assessments of ship vibration to assess compliance with habitability criteria, as well as assessing potentially damaging vibration, assisting with noise and vibration specification review and development to identify appropriate limits for vessels based on the mission. We then work with owners and operators to ensure the vessel's goals are met at sea trials, and performing noise and vibration compliance and diagnostic testing. For more detailed information on our capabilities, please refer to other noise control engineering's information on a Navy STP virtual transition marketplace and our website. Now on to the specifics of our current SBIR project. In the interest of helping lower the risk of noise-induced hearing loss, Noise Control Engineering was awarded a Phase 1 SBIR grant to investigate how to reduce noise from abrasive blasting nozzles. These are used extensively in maintenance applications, not only in shipyards, but in many commercial and industrial settings. Abrasive blasting is used for paint and surface coating removal and refurbishment at shipyards, maintenance facilities, and factories, and in manufacturing, bridge and building construction, and civil structures such as dam spill gates at hydroelectric plants. The physics of a blast nozzle are similar to that of an aircraft engine exhaust nozzle, producing very high noise levels. However, unlike an aircraft engine, the operator of an abrasive blaster is very close to the noise source, which can reach noise levels as high as 130 decibels and presents a significant hazard for hearing loss. The objectives of our research are to reduce nozzle noise levels by 20 decibels and increase nozzle efficiency by 20%. Greater nozzle efficiency means operators will be able to finish their work faster, and the less time they spend blasting, the less time they will be exposed to blasting noise overall. By achieving our objectives, hearing loss and safety risks will be reduced, speed and performance will be increased, and the cost of completing the activity will be lowered. Proprietary methodologies are being employed to reduce turbulence-generated noise, as well as other factors that generate high noise levels. Noise Control Engineering's extensive acoustic testing experience and modeling capabilities have enabled us to make progress towards our objectives. Our methods include the following: modeling blasting abrasive and air in nozzles using computational fluid dynamic techniques, using these computational fluid dynamic results as inputs for acoustical models to predict noise, performing optimization of geometries to reduce noise and increase efficiency, manufacturing and testing prototype nozzles, correlating test results with models and making updates, and repeating our design optimization test feedback loop to continue design improvements. We are currently working in the SBIR Phase 2 option period, and as with previously successful projects, the project is currently on budget, on schedule, and is progressing towards meeting project objectives. The approach we have taken, that of design, manufacture, test, and refine models based on the test data, has been successful in progressing towards the project goals. We are currently developing our third set of prototype nozzles and have a number of candidates which perform well in both noise and efficiency. We are continuing to explore nozzle configurations and features in order to find the optimal design that will decrease noise while also increasing nozzle efficiency. As previously discussed, decreases in noise levels and increases in efficiency will reduce safety risks, increase nozzle performance through higher efficiency, decrease time needed to perform tasks, and result in cost savings to perform the work. The net effect of this successful product would be an increase in task performance while reducing the cost and time to perform an abrasive blasting task. To digress slightly to our capabilities, Noise control engineering has been very successful in the past in developing technology to reduce costs, increase performance, and even improve schedules. One example of this is our buoy acoustic measurement system known as BAMS. BAMS was internally developed using our own resources and is deployable when underwater radiated noise compliance and diagnostics are needed. It is a portable device that provides affordable, calibrated underwater sound pressure measurements. It can be deployed anywhere in the world for design acceptance, recertification, diagnostic tests, and other compliance type assessments without requiring a fixed underwater noise test range. This capability costs about one-tenth as much, if not less, and takes significantly less time than having to transit a vessel to an underwater range and pay high range fees for its use. BAMs can also help ship owners and operators understand underwater radiated noise and identify mitigation strategies, and our engineering services group can provide underwater signature assessments to determine compliance with design and environmental objectives. Cost, performance, schedule, very important parameters. As abrasive nozzles are pretty much a commodity item, the likely transition to the fleet will be through some sort of catalog purchase, probably GSA. The options for the manufacturing part of the transition are still under consideration and will be discussed in a subsequent slide, but we have a history of success in transitioning technology. The designer noise software and the damping treatment have already been discussed, but success has also been achieved when technology developed under our O&R contracts was successfully transitioned to other government agencies, namely the Bureau of Reclamation. In cooperation with O&R, Noise Control Engineering became the prime contractor for reclamation in a major program to reduce noise in their hydropower plants. We conducted noise surveys in 34 reclamation plants, including the Hoover Dam and Grand Coulee power plants, and have successfully implemented engineering noise controls in 20 of these facilities, significantly reducing noise levels. The success of these land-based projects has direct applicability to NAVFAC, the Naval Facility Engineering System Command. Among the responsibilities of NAVFAC is the construction and maintenance of many of the U.S. Navy's land-based facilities, including but not limited to naval shipyards and naval-based facilities, housing, medical facilities, engineering and training centers, as well as shore facilities. Many NAVFAC facilities are in high noise areas, and based on our experience with reclamation, we have the proven expertise to help reduce noise and lower the health risk for personnel working and living in high noise facilities. Getting back to the current SBIR topic, the global market for abrasive blasting nozzles is estimated to be about $200 million a year, with an expected growth rate of 5% per year over the next 7 years. A more efficient and quieter abrasive blasting nozzle has commercial applications across several major industries. The marine industry represents the largest market opportunity given the widespread use of abrasive blasting in naval shipyards and maintenance facilities. The automotive, construction, aerospace, metals and mining, and oil and gas industries also utilize abrasive blasting for a variety of purposes. Conversations with marketing managers and technical experts affiliated with manufacturers and distributors of abrasive blasting nozzles have indicated a high level of interest in quieter and more efficient nozzles. We envision two options for our transition plan. These are a licensing agreement with a manufacturer, which is likely, or a partnership with a manufacturer and market directly, which is less likely. Discussions with several existing manufacturers suggest that a more efficient, reduced noise nozzle could command a premium price point. We will use our past experiences with successful transitions, as has already been discussed, to develop an effective transition process for the quieter, more efficient abrasive blasting nozzle. Thank you for listening. Our contact information is on this slide. Please get in touch if you'd like more information or if you have any questions. Thanks.